Yo, 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 this is Mr. O. Yo, 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 this is Mr. O, and today we're going to learn about solving exponential equation. In solving exponential equation without logarithm, the idea here is that for the same side of the equation to have the same base. Okay, so here are some step or guidelines that will help us to solve exponential equation. First, you have to use the properties of exponent to simplify each side of the equation. So when you're given an equation, on the left side, you have to simplify whatever you can combine and apply the rules of exponent, and also on the right side. Now, when they're all simplified, you go to step two. Rewrite the equation so both sides have the same base. The idea is to make their bases the same. And what if they're not the same bases? That's a different topic that we're gonna learn. Okay. So right now, the goal is to find a way to make their bases the same. Drop the bases and set the exponent equal to each other. So once their base is the same, remove the bases, focus on the exponent and set them equal and solve from there. Okay. So let's go ahead now here. Let's go with let's fix this one here. Same base. If we have 2 to the x equals 2, we know that the base here are the same. They're both base of 2. And then we have here 2 to the x equals 2. What's the invisible base here? What's the invisible exponent here? It's 1. So since they have the same base here, we drop that down and x is equal to 1, right? Because their base is the same. That was too easy. Here, next, 3 to the x minus 4 is equal to 3 to the 2x minus 3. They have the same base. Now we can cancel this out and focus ourselves with their exponent. So we have x minus 4 equals 2x minus 3. Solve for it. I'm going to subtract x here, subtract x here. I'm going to add 3 here, add 3 there. This will cancel. So I will have now x equal to negative 1. And that's the answer. What if we have some more expression on one side like this? 5 to the d times 5 to the d minus 2 equals 5d, 3d plus 6. Focus on this one here. As part of our step, we have to apply and simplify the rules of exponent each side. So here I can combine this because it's multiplication. I will add the exponent. And they have now 5d plus d minus 2 is equal to 3d plus 6. We all know that 2d's, d plus d will be just 2d, so I can just erase this one here and make it 2d minus 2. Now they have the same base. I can eliminate that and focus myself on the exponent. 2d minus 2 is equal to 3d plus 6. So now I can subtract 2d here, subtract 2d here, minus 6 here, minus 6 here. This cancel out, this cancel out. So 3d minus 2d is just d. Negative 2 minus 6 is negative 8, and that's the answer. So what if their bases are not the same? Like here, 2 to the x equals 8. I know that 8 can be written as 2 to the third power because 2 times 2 times 2 is equal to 8, right? So now they have the same base. I can focus myself on the exponent, so therefore x equal to 3. Let's go here. 3 to the x minus 5 equals 27. Again, they don't have the same base, but can you make their base the same? Let's try. We know that 3 to the x minus 5 will be equal to 3 to the third power because 3 times 3 times 3 is equal to 27. And then now we can focus ourselves with the exponent x minus 5 equals 3 plus 5 here plus 5 there. So therefore, x equal to 8. Next, 9 to the 2x equals 1 over 81. They don't have the same base. I have 1 over 81. We're going to try to make their base the same. But hold on. it's in the denominator. The 81 is in the bottom part. So what do we know first about 81? We know that 81 is 9 squared because 9 times 9 is 81. Now I need to bring this up so they will have the same level as the base on the left side. So 9 to x, if I bring this up, it becomes 9 negative 2 because you change the position. The 1 there is just like multiply it by 1, which 1 times anything is just going to be itself. So I can leave it at 9 to the negative 2. Now they have the same base. I can focus now myself to the denominator, to the exponent. 2x equals negative 2. So therefore x equal to negative 1. Next, 16 raised to the 2y minus 1 equals 4 to the x minus 2. They do not have the same base, but I can make their base the same. I know that 16 is 4 squared. Pay attention here. If there's a 4 squared here equals 16, but there's a 2y minus 1, I will put a parenthesis here and put 2y minus 1 there. Because the 16 is the 4 squared. 2y minus 1, I just drop it down. 4x minus 2. Now you will see they have the same base, so I can focus myself on the exponent. Then I'll have 2y minus 1 is equal to x minus 2. On this case here, I think I messed up. This should have been x here. This should have been x. That should be x. They need to have the same variable. Okay, my bad. Now we can distribute the 2 there. That will give us 2 times 2x is 4x. 2 times negative 1 is negative 2 equals x minus 2. Now solve it by subtracting x here, subtract x here, add 2 there, add 2 here. This will cancel, this will cancel, this will cancel. That will give us 3 equals 0. Take note that this is a portion that common mistake of the kid that they think is no solution and they are wrong here. There's a solution. No, Mr. O, 3x equals is not equal to 0. I know 3 is not equal to 0, but there's a 3x there. You can still continue by dividing it by 3 here, and x is equal to 0 divided by 3 is 0. So it still works. So do not think it's no solution when you see 3x equals 0 or a 5x equal to 0. Okay, you can still solve it. But if you end up with 5 not 5 equals 0, then that's the time it's going to be no solution. Okay, there's no variable already anymore there. Let's go to some challenging question here. 9 to the 2x plus 4 times 9 to the 2x equals 181. It's very similar to what we have done so far. We just combine it. First, remember I told you you have to simplify the one side of the equation by applying the rules of exponent. And you know that 9 are the same base. So I can add this two set of exponent. This will be 2x plus 4 plus 2x. And I know that 81 is same thing as 1 over 9 squared. And I will combine this, simplify this. This will be 9 4x plus 4. And the squared, the 9 squared will go up, becomes negative 2. Now they have the same exponent, so same base, I mean. So this becomes 4x plus 4 is equal to negative 2. And from here, we can solve it by moving the minus 4, moving the 4 there. This will give us 4x is equal to negative 6. Then therefore divide by 4, divide by 4, x equal to negative 6 over 4, or better to say is negative 3 halves. And that's the answer. Kaboom. 2 times 4 to the 3x minus 1 equals 1. 8 times 4 to x plus 5. Oh, Mr. O, there's a base of 2, there's a base of 4, a base of 8. Take note, all the numbers that I've mentioned, 2, 4, 8, are all can be changed their bases into 2's. 2 is 2 to the 1, remember that. 4 is same thing as 2 squared, but there's a 3x minus 1, so I'm going to put here parenthesis of 3x minus 1. And we know 1/8 is same thing as 2 to the third power, so this is still base of 2 now. And 4 is same thing as 2 squared, and then put there 2x plus 5. Okay, so if you notice, I have made all my bases to 2. Now it's the time to simplify it. Okay, so since I have a 1 here, remember you're going to add it to the exponent. So this will be now 2 to the 1 plus 2 3x minus 1 is equal to, I'm going to bring this up, that makes it 2 to the negative 3 times 2 to the 2x plus 5. Now, all their bases are the same, but hold on, I can still combine these two here. Simplify it first. Don't cancel it yet. That's a common mistake of the student. They'll try, oh, they're all base of 2, cancel it now. No, that's wrong. Don't do it yet because we can still simplify this side of the equation here, okay? So this will be now, let's simplify this one here. This will be 1 plus, this distribute this 2 here, give us 6x minus 2 is equal to, now here, what can we do with the negative 3 and with this? We're going to add them, 2 to the negative 3 plus, I'll try to distribute this one here now, 4x plus 10. All right, let's get some space here. All right, now we have the same base here. We can focus ourselves with the exponent. 1 minus 2 is negative 1 plus 6x. Negative 3 plus 10 is what? 7 plus 4x. Now is the time to combine the like terms. I'm going to subtract 4x here, subtract 4x here, plus 1 here, plus 1 there, cancel this, cancel this. That will give us 6x minus 4x is 2x, 1 plus 7 is 8, so therefore x equal to 4. Kaboom. And that's how you solve exponential equation. And as always, kaboom.